Hello, Dr. Abdullah. I hope you are well. My name is Sal Hababe, and in this project, I will going to talk about Fullerene. I will cover in this presentation these topics: the introduction of Fullerene family, the Fullerene, how we discover it, and how we get the name Fullerene, type of Fullerene and related structure, the properties, and synthesis to how we can fabricate, and at the end, the potential and current applications. What is fullerene? A fullerene is a molecule composite entirely of carbon, in the form of hollow, sphere, ellipsoid, or tube. Spherical fullerenes are also called buckyballs, and cylindrical ones are called carbon nanotubes or buckytubes. Fullerene history. The existence of C60 was predicted by J. Izawa of Toyohashi University of Technology in Japan magazine in 1970. With mass spectrometry, discrete peaks were observed corresponding to molecules with the exact mass of 60 or 70 or more carbon atoms. In 1985, Harold Kuroto discovered C60 and shortly thereafter came to discover the fullerene. Kuroto, Karl, and Gemelli were awarded the 1996 Nobel Prize in Chemistry for their roles in the discovery of this class of compounds. Minute quantity of the fullerenes in the form of C60, C70, C76, and C84 molecules are produced in nature, hidden in soot and formed by lightning discharges in the atmosphere. Discovery of carbon C60. In 1985, Robert Kerr discovered a new form of carbon that 60 or 70 carbon atoms could cluster together to form a gas-like molecule. The molecular structure resembled the pattern of sugar ball or the geodesic design of Buckminster fullerenes, thus the name Buckballs or fullerenes. Since then, the discovery had led to new research in polymers, semiconductors, and other various areas, and they took Nobel Prize to their founders in 1996. The existence in the nature. In 1992, fullerenes were found in a family of minerals known as shungites in Karelia, Russia. In 2010, fullerene 60 have been discovered in a cloud of comets dust surrounding a distant star 6,050 light years away. Using NASA Spitzer Infrared Telescope, the scientists spotted the molecule's unmistakable infrared signature. Sir Harry Kuroto, who shared the 1996 Nobel Prize, as I said before, in chemistry for the discovery of buckyballs, mentioned that the most exciting breakthrough provides convincing evidence that the buckyball has, as a long suspected, existed since time immemorial in the dark rises of our galaxy. Naming of fullerenes. The substance of fullerene was named after the American inventor, architect, and philosopher Richard Buckminster Fullerene (1895 till 1983). As an architect, Robert Buckminster Fuller designed the construction, which consists of 5 corners and 6 corners, and also fullerenes are similar in structure to graphite, which is composed of stacked graphene sheets of linked diagonal rings, but they may also contain rectangular or sometimes heptagonal rings. And here you can see some fullerene models from C56 to C76. C56 TD model, C56 TD, C58 C3V, C76 D2, C72 D6D, C60, C2V, and C60, C2V, and yes, these are some models of Fullerenes. And here you can see some different structure pachypods. Another fairly common Fullerenes is C70, but Fullerenes with 72, 76, 84, and even up to 100 carbon atoms are commonly obtained. In the mathematical terms of the structure of Fullerenes is a trivalent convex polyhedron with pentagonal and hexagonal faces. In graph theory, the term Fullerene refers to an irregular planar graph with all faces of size 5 or 6, including the external face. It follows from Euler polyhedron formula V minus E plus F equal to, which V means vertex and E means edges and F faces. That there are exactly 12 pentagons in Fullerenes and V divided by 2 minus 10 hexagons. Fullerene family. Diamond, graphite, and the two-type fullerenes, the old fullerene and the double-point fullerene. A schematic representation of structures of graphite, diamond, and fullerene. While the two-dimensional sheets formed by hexagons and are packed one over another in graphite, the diamond structure is three-dimensional. Only two fullerenes are shown. As I said, the smaller one is Buckminster fullerene C60. The, the other one is called double bonds are localized exocyclic to the pentagons giving 5 radialine character to the pentagons and cyclohexa 135 ternary character to the hexagons. Synthesis discovery of C60. In this picture, you will see the experiment setup used to discover C60. The graphite disk is evaporated with a ND-YAG laser and the evaporated carbon plasma is cooled by a stream of helium coming from a cluster valve. The cluster of carbon are protected in the integration cup and are expanded into vacuum. The ions are detected by time of flight mass spectrometry. And the purification of fullerenes related to schematic illustration of the process involved in the synthesis and purification of fullerenes. Graphite rods are evaporated in an arc under helium atmosphere. The soot collected is extracted with toluene and subjected to chromatography. And least and not last, the probabilities and applications of fullerene. In April 2003, fullerenes were under study of potential medicinal use, binding a specific antibiotic to the structure to target resistant bacteria and even target certain cancer cells. Use of fullerenes as light-activated antimicrobial agents, and fullerenes are stable but not totally unreactive. There are so many applications of fullerenes. The first one, solubility. Fullerenes are sparingly soluble in many solvents. Solution of pure Buckminster fullerenes have a deep purple color. Solution of C70 are reddish-brown, and the higher fullerenes C76 to C84 have a variety of colors. Now, the second application of fullerene, hydrated fullerene. Hydrated Fullerene's C60HYFN is a stable, highly hydrophilic supramolecular complex consisting of C60 fullerene molecule enclosed into the first hydrated shell that contains 24 water molecules. And the last application of fullerene is that fullerene is a superconductor. The intercalation of alkyl metal atoms in solid C60 leads to metallic behavior. In 1991, it was revealed that potassium-doped C60 becomes superconducting at 18 Kelvin. This was the highest transition temperature for a molecular superconductor. Since then, superconductivity has been reported in Fullerene's up with various other alkene metals. And I will end my presentation with the properties of fullerenes. Fullerene is a black powder material and form deep magnet solution in benzene. Very tough and thermally stable. Exists as a discrete molecule unlike the other two allotropes of carbon, which are graphite and diamond, and also can be compressed to lose 30% of its volume without destroying its carbon gauge. And thank you for listening, and I hope you enjoy my presentation. Stay safe.